Hello everyone! We are the small group of robot enthusiasts with experience in information technology, electronics and mechanical engineering and would like to share our experience in building inexpensive robots and electronic devices for education and practicing. There is a lot of information on how to build various robots using navigation and simultaneous localization and mapping, which is abbreviated as SLAM. However, to build and program this type of robots seems to be very complicated and expensive. Our goal is to show how to build inexpensive robots easily using existing components, published resources, and utilizing robot operating system ROS2. Currently, ROS2 is widely used in many areas from humanoid robots to industrial robots and autonomous vehicles. In a few videos, we will demonstrate how to build security robot with mapping and navigation using Robot Create 3 Kit, inexpensive LiDAR and blink security cameras. Robot built on ROS2 platform. Here is our robot generated map using LiDAR and SLAM technology. And we'll check how robot navigate around the room based on desired route shown on the map as thin red dotted line. On the lower right part of the screen, you also can see our real-time moving robot automatically undocking from charging station, following the route, reaching final goal, and then returning back and docking to the charging station. The robot automatically chooses the shortest route to the final point and back to the charging station based on generated map. The robot also avoiding obstacles. On the map you can see moving simulated robot real time as well. In the next section of this video, we will show capability of our robot and how to generate a map, set navigation points, autonomously drive the robot and take videos while moving. Since this is overview video, we assume that ROS2 installed, Create 3 and TurtleBot 4 Lite packages loaded and room map generated. To do all that, we just need to follow published documentation on Create 3 and TurtleBot 4 websites. Please let us know in the comments below if there is an interest in how we did full system installation and setup, so we know if it makes sense to create more content and video on this. Let us create a route for our robot to navigate around the room or office. First, we open 3 terminals on Ubuntu PC and logged in on each terminal via SSH to your robot Raspberry Pi computer. I'm using Terminator application for Ubuntu. On each terminal, we sourced ROS2 environment and set ROS2 middleware interface, which is RMW, as you can see on the picture. Then, on Terminal 1, we initiate and launch LiDAR. On Terminal 2, we start navigation with generated map described in the documentation I mentioned a bit earlier. On Terminal 3, we run ROS2 topic to display coordinates of clicked point on the map. Please note, we will see coordinates here after we set point on the map, otherwise it will be no coordinates listed. Open new terminal on Ubuntu PC and source ROS2 environment as shown on the picture. Then, on the desktop PC, we execute command to interact with navigation and map starting Visual Tool calling RViz as shown on the screen. Then on RViz map we click on 2D pose estimate and set our robot direction on the map. Then select the Publish Point tool and clicked on a place on the map. You should see the robot location coordinates published in the Terminal 3. We should capture coordinates at least at the end of the route where our final destination is, and then on the way back closer to docking station, so robot will be able to find it. We are using these coordinates to include them in the Python script for automatic navigation. For that purpose, with the text editor, we open nav2pose.py script and modify coordinates which define the automatic route. In my example, I have 4 points, 2 points to the end of route and 2 points going back. After modification, we have to save the script. At this point, we are ready to start navigation and capture images or record videos while the robot is moving. To do it, we just need to execute nav2pose.py script on Terminal 3 and voila! Our robot automatically undocks, moves toward the goal, makes picture or records videos while moving using Blink app, reach final destination and returns back and docks to the charging station. All done automatically. If you like this video, please provide your feedback or suggestions, and please subscribe to this channel so we know if there is an interest to build and configure the robot, generate the map, automatic navigation, and also if there is a desire for future simple and inexpensive robot development and electronic projects using available online resources.